So this is our last reaction for this chapter, the Robinson annulation. And it's actually a combination reaction that combines the Michael reaction with an intramolecular aldol reaction. So let me show you. The starting materials are a carbonyl compound. So carbonyl compound, this is the one that's going to form your enolate. And an alpha beta unsaturated carbonyl. So same starting materials that we had for our Michael reaction. It's going to form a 6-membered ring at the end of this and 3 new carbon-carbon bonds. So this is going to give us a 6-membered ring with 3 new carbon-carbon bonds. Let me show you step by step what the reaction is, and then we can go through the mechanism. So the first thing we have is our Michael acceptor and our Michael donor. So if our acceptor looks like this, that's our alpha beta unsaturated carbonyl, and our donor looks like this. After we use our strong base and we do our Michael reaction, our intermediate, or the end of that step, looks like this. There's our product of our Michael reaction. If we have enough base in solution, we can then do an aldol reaction, because we know aldol reactions happen with base. And what this ends up doing is an intramolecular aldol reaction. We close up the ring, and we have our piece left over here. So you do your Michael reaction first, and then we do our intramolecular aldol reaction. So how do we decide what our products are going to look like from the beginning of this to the end? Let me show you. Here's our products. So first thing you want to do is you want to draw your Michael acceptor like this. So you want your carbonyl sticking down to the bottom left, and then the double bond up on top of it. Then we want to draw our donor over here, whatever that looks like. And let's draw some dots. This is going to be our alpha carbon, where we're going to pull hydrogen off of. We know that's going to connect over here to the the beta carbon of this alpha beta unsaturated ketone. So these 2 dots are going to form a bond. We also know that in an aldol reaction, this is going to be the alpha carbon that gets deprotonated, and this carbonyl carbon is going to be where it attaches. So we're going to have a bond there. And because this will eventually be an OH that will leave when we do a dehydration, this is where our double bond is going to form. So if we drew the product of this particular reaction, our product would look like this. Carbonyl, and then our ketone, or our alpha beta unsaturated ketone, got attached here. That methyl group is still on there, so we formed that bond. And then down here, we're going to form a double bond to the ring there because that's where our other carbonyl was. So that's our product. If we want to think about it retrosynthetically, you want to locate the 2-cyclohexenone ring. So here's our 2-cyclohexenone ring. And you're going to redraw your target so that the carbonyl is pointing left and down with the alkene to the right of it. That's always how you want to do it. And you're going to break the double bond. And then you're going to break the bond that is 2 away from the double bond. Reform your alpha-beta unsaturated ketone on the left from these parts. And reform your carbonyl on the right from these parts, knowing that the carbonyl part is going to be right where it connected here. Let me give you one more example. So what are the starting materials for the following products? Let's see. If this was formed, oh, that's not an oxygen, sorry. If this was formed from a Robinson annulation, how would it be formed? Well, let's manipulate our molecule. Let's look at what our parts are. We've got a carbonyl here and an alpha-beta unsaturated ketone here. So this is the double bond that formed. The other bond that formed must have been this one down here. And so our first part is going to come from this. And our second part is going to come from this whole thing over here. So let's draw our first part. Our first part has carbonyl here, this thing here, this thing down here, and that's where the double bond was because that's where it connected. Our second part over here looked like this. Keep wanting to draw an O up there, and there's not an O. Looks like this. And we know it was connected here, and so that's where the double bond to O goes. Hope you've enjoyed this lecture. Catch you in class.